Okay, so when you're simplifying the expression, what you are trying to do is you are trying to take out any perfect root. So if the index number is 3, it's a cube root, okay? And you can think of this in a few different ways. So if you remember this from last year, in a moment I'll explain to you how you can think about it. But remember, we just went over all of these rules, and you can rewrite this as a product of two values. And yesterday we talked about our rules with exponents. So x to the 4th, that is the same thing as the cube root of x to the 3rd times x. Remember, if you're multiplying with the same base, what do you do with the exponents? You add them. So 3 plus 1 is going to be 4. Now, the reason why I'm showing it to you like that is because if you break this apart using this first rule in our table, it's really simple for you to see that the cube root and 3 are going to cancel out, and what would you be left with? X. Yep. And then here you'd have the cube root of x. So this would be your final answer. This would be your simplified answer here. Okay? You do not have to write it out like that. Like I said, if you remember how to do that, you're probably doing a different process in your head. So a way that we talked about this in previous math courses is I would say, okay, how many times does 3 go into 4? How many times? 1 time. So 1x comes out, and then there'd be 1 left over, and that has to stay inside. Okay, so the rule is, in order to take something out, you have to have this number of factors. So in this case, you have to have 3 factors. Okay, you have 3 x's, so that one comes out. Okay, and then we're going to do something similar with this one. So when you have multiple variables and you have a number, you are going to think of those separately. So I always think of the 4th root of 81, that I'm going to simplify that differently than I would simplify the 4th root of x to the 8th and the 4th root of y to the 4th. Okay, so if you don't know the 4th root of 81 off the top of your head, that's okay. I know that most of you do now because we've talked about it a few times. But you have to find what factors go into 81. And if there's a group of 4 of them, which in this case is 3, that is going to come out. So 3 is going to be part of your final answer. How many times does 4 go into 8? Twice. So this would be x squared. How many times does 4 go into itself? Once. Okay, and then once you have that written down, if you can just hold up a number between 0 and 5 with how confident you are at remembering these, can you just put that in front of yourself so I can kind of see where we're at and see if we need some more review on that. All right. You guys are feeling confident. I like it. Okay, so on the back page, we're going to talk about adding square roots. So when can you add square roots together? Do you guys remember the rules? There's really 2 things that have to happen if you can add the square roots. Yeah, so you have to have the same number underneath the root. Okay, so you have to have the same value underneath the root. Do you guys remember what that's called? The number underneath? No? Yeah, the radicand. Yep, so you have to have the same root. Okay, so they have to be either the square root, the cube root, the 4th root, and you have to have the same radicand. Yes. Yep, that will be your index. We reviewed that today. Okay, so the same root and the same radicand, so the same number underneath. Okay, so let's do a few examples. It says give an example with your explanation. So we're just going to do the examples together. Okay, so the first one is we're going to do 4 root 2 plus 10 root 2. That is something they should have done in algebra 2. So if they have the same root and the same radicand, do you guys remember the rule? What do you add together? Yep, you just add the numbers in front of the radical. So the radical stays the same. It's very much like adding variables. So 4x and 10x would be 14x. It's just we don't have x, we have root 2. So this would just be 14 root 2. Okay, and then last year, you guys had some harder examples, like you had some hidden roots in there. So this is the cube root of 16 plus the cube root of 2. Now at first glance, those don't look like they're the same, but remember, with every single radical, you have to simplify. And that means there could be perfect squares hiding in here. What perfect square is hiding in 16? 2 times. 2 times what? 8. 8 is the perfect cube. Okay, so the cube root of 16 is the same thing as the cube root of 8 times the cube root of 2. Okay, so the cube root of 8 is 2. So this is really 2 cube root of 2 plus the cube root of 2. And then go ahead and guess what your answer is going to be there. So remember, you're adding the numbers in front together. In the second one, the cube root of 2, what number is in front there? A 1. So your final answer should start with what? 3. Your final answer should start with 3. So it's going to be 3 cube root of 2. And again, it's because there's a 1 here. So you're adding the 2 and the 1 to get the 3. Okay, so your textbook warns you not to make this error. This happens often. This is a common mistake. You cannot take 2 values that are added and split them up. This is not the same. We're going to draw a big no through this. These are not equal. Okay, so because it works with multiplication, people just assume it also works with addition. A very quick way to prove that, this is my favorite example to use, is if you have the square root of 9 plus 16. So if you were to break it up like that, that means that these should be equal, right? But what's the square root of 9? 3. Square root of 16 is 4, so that would make 7. And then this would be the square root of 25, which we know is 5. Are those equal? No, so that cannot happen. Okay, so this does not transfer to addition. It's only going to work if you're multiplying or if you're dividing. Okay, now some of you already reviewed some of the rational exponent rules when you were doing your practice yesterday. So remember that when we say a rational exponent, all that means is it's a fraction. So a rational exponent is an exponent that's a fraction. Okay, and then the fraction is going to relate to roots and it's going to relate to powers. So when you are defining the nth root, if you have a base that's raised to the power of 1 over n, that is the same thing as taking the nth root of a. So that means if you have a to the 1/2 power, that's the same thing as doing what? Taking the square root. Yeah. So that's the same thing as the square root of a. And then if you have the cube root of b, that's the same thing as writing b to what power? 1/3. Yeah. So those are interchangeable. Okay. And if you started the practice yesterday and you're like, oh, I do not remember how to rewrite these with rational exponents and powers, this is going to help you today. So whenever you have a value that's a to the m over n, you can rewrite it like this. You can rewrite it as the nth root of a, and you can raise that to the nth power. This is going to be the most common way. Or you could do the nth root of a, and you could put the power inside the radical. So the power can go outside or inside. Do any of you remember what I may have told you in the past about how I remember that? Which one's the root? Which one's the root's on the bottom because yes, because trees. Yes, because in a tree the root is where? Yeah, in the ground. Okay, and then for the power, if you're on top, you got the power. So I draw a little crown. There's my crown. Put some jewels on it. There it is. Okay, so if you're on top, you got the power. Roots grow in the ground. That's how I remember it. You can use that to help, or you can come up with your own way. So with that definition, it can be proved that the laws of exponents also hold for rational exponents. So all of the laws that we talked about when you're multiplying, you add your exponents together. The same thing is going to be true with rational exponents. We're going to add those together. So we're going to rewrite 16 to the power 3/4 in 2 ways. And then we're going to put a star by the way that was easier to do without our calculator. So you can write this as the 4th root of 16 to the 3rd. That would be one way to do it. And then the other way I'm going to put over here so we can do this. The other way would be the 4th root of 16 in parentheses and raise that to the 3rd power. Okay, so do we remember what the 4th root of 16 is? Yep, 2. And then 2 to the 3rd power is 8. Do you guys know what 16 times 16 times 16 is? Anybody really want to do that out? I'm just going to tell you. 4,096. Okay, so if you do the 4th root of 4096, who wants to do the factor tree? We start with 2, we keep cutting it in half, and eventually we would find out that it's 8. So which one is easier to simplify without your calc? The second one. So this is going to be the way that you're going to want to do that. Okay, obviously if you were doing an SAT and this was on a calculator portion, then you could do that out. But this one is going to be a no calculator portion, so you're going to want to do this when you're not using a calculator. Okay?
Wait, how do you do this?
Oh, this one, so we do the 4th root of 16. So with 16, you can just write that down, 2 and 8. And sometimes what I'll do with 8 is, we know this is 2 to the 3rd, right? So you have 2 to the 4th. Okay. And so make sure you are practicing those without a calculator. Your quiz will be no calculator. So really, most of your work is going to come from your practice and kind of using those muscles again, because I don't think many of us worked them out during the summer because we were chilling, right? Okay, so now we're getting back into mathematical shape. All right, so rationalizing the denominator, when you're rationalizing the denominator, why do we multiply both the numerator and denominator by the same value? So we have to do that. Why do you have to make sure that you do that to top and bottom? Yeah, Anna? Yeah, it won't be an equivalent fraction. It is equivalent if you multiply the same number to the top and the bottom, because what is that equivalent to? Yes. Okay, so we multiply both the numerator and denominator because we need to multiply by a value equal to 1. The value of the fraction stays the same. Right, so we need to multiply by a value equal to 1 because that means the value of the fraction stays the same. Okay, the fancy way to say that is it's a multiplicative identity. When you multiply something by 1, you will always get the same thing. Okay, when you multiply something by 1, it's the same value. So that's why we're able to do that. Okay, so now we're going to think about some other stuff that we've done before. So if you have a denominator that's the 6th root of a to the 4th, what would you multiply the numerator and denominator by? What would you multiply the numerator and denominator by? And then I said, I just said explain by showing mathematical steps. So, and then I'll give you that formula. So let's say you have this. Let's say you had 1 over the 6th root of a to the 4th. Okay, I want you, I just gave you a hint, has to be the 6th root of something. Think about what you're going to multiply by, and then why. So remember, the goal is to undo the radical, okay? So if it's the 6th root, how many factors do I need to undo the radical? 6. I need 6 altogether. How many do I have? 4. So how many more do I need? 2. So if you said you were multiplying by the 6th root of a squared, you are correct.
Yes.
Yeah. Okay. So the 6th root of a to the 4th times the 6th root of a squared is going to be the 6th root of a to the 6th. Okay, and then those would cancel out. So what would you be left with on the bottom? A. Okay, and then the top would just be the 6th root of a squared. And you can't simplify that anymore. This number inside the radical should always be less than your index number. So if this is more than that, you can simplify. If it's less than, you're good. Okay? Now, the book, if you are having trouble figuring that out, they give you a formula that you can use. So the formula is this. Okay? You can multiply by the nth root of a to the power of n minus m. We'll talk about what those are in this example. Okay, so in this case, okay, this would be the nth root of a to the m power. So if you were to do that, you'd have the 6th root of a to the 4th is what I asked you about. So it'd be the 6th root of a to the 6 minus 4. And then look, this is what you'd multiply by. See how this is what we put here? This is how you can figure out what to multiply by. Okay, so you always just subtract. 6 minus 4 is 2, so I'm going to multiply by a squared. Same radical. Okay, so based on this, I want you to try part A. Once you conquer part A, you can start thinking about part B. And remember, you should have no perfect squares in your radical. I kind of want you to take that just to All right, how are we doing with this? What's the exponent on x if you can't see it? It's 1. Sorry, that looks really minute. Okay, so what's 4 minus 1? 3. So you should multiply the top and the bottom by the 4th root of x cubed. Okay, so then on the bottom, that would be the 4th root of x to the 4th, which will just be x. Okay, and then on the top, if you are multiplying something in a radical by something that's outside a radical, you cannot put that inside. Whatever's inside has to stay inside, whatever's outside has to stay outside. Okay, so you're just going to multiply straight across like you do with your fractions. Okay? All right, now if you were to use this formula here, you would get a negative number. You cannot multiply by negative exponents. Okay, so instead, you have 2 options. Okay, you can either simplify that first, then multiply using your formula, or you can just go to the next multiple of 6. Okay, what's the next multiple after 6? 12, good. Because 6 times 1 is 6, 6 times 2 is 12, 12 is the next multiple. So how many more would I need in order to get 12? Okay, so this is one method. You could multiply by the 6th root of a to the 4th. Okay, so if you did that, how many times does 6 go into 12? Twice. So it would be a squared. And then you would just keep the 6th root of a to the 4th on the top. Okay, the second method is you can simplify first. So if you simplify that first, then you can say, all right, 6 goes into 8, how many times? 1 time, how many would I have left over? 2. So then you could use your formula. 6 minus 2 is 4. See how you end up multiplying by the same thing? The only difference is now, when you're looking at the numerator, when you multiply these together, you get the 6th root of a to the 6, but you're still multiplying that by a. Okay, so this is going to be a times a on the bottom, which is, yep, and then I'm actually just going to draw an arrow. You don't have to write it twice. It's the same thing. Yeah, I like option 1 too, just sometimes people get confused with the multiple. So you can choose whichever one works best for you. Alright, so I'm going to give you some time right now to finish your 1.2 homework. I'm going to put that up for you.